Good morning, my dear students. Today I will teach you a very interesting topic of computer science from chapter 1, which is AND logic gate. Before starting, let me share my screen first. Starting AND gate, I would like to explain what is a logic gate. So, as you can see, I have written the definition of logic gate, that a logic gate is an idealized model of computation or physical electronic device implementing a Boolean function. A logic gate operation performed on one or more binary inputs that produce a single binary output. I know that understanding the concept from this definition is quite difficult. Let me explain you easily. You can think of a logic gate is a electronic component which takes some inputs in form of signals and produce some output. I will explain it deeper by time. The AND logic gate works exactly in the same way we use the word AND in real life. Let's take an example how we can use the word AND in real life. Suppose you met me yesterday and I told you that Ram will come and Sam will come. Let me write it down. Ram will come and Sam will come. Here there is four possibilities. Ram may come or may not come, and Sam also may come and may not come. Let's see all those possibilities. Here I took the statement. I am using the term statement because a statement is a sentence which can either be true or false. I break down the statement into some smaller pieces. First one is Ram will come and second one is Sam will come. And the word and is connecting both the statements. I am assuming P equal to Ram will come. Let me write it down. And Q equal to Sam will come. Then we can rewrite the statement as P and Q. If we represent the word and using a dot symbol, we can get that P dot Q. Here P represent Ram will come, dot represents and, Q represents Sam will come. In reality, there can be four possible combinations of P and Q. Let me write it down using a table format. P, Q, P dot Q. First case can happen that Ram is absent and Sam is also absent. In reality, you see that Ram is absent and Sam is absent. That means P statement is false and Q statement is false, which is case 1. I am writing it down. Case 1. So if P statement is false and Q statement is false, that means none of Ram and Sam come today. So the statement I told you yesterday is false. That means P dot Q is false. I am considering case number 2. Case number 2. It may happen that P statement is false, that means Ram is absent, and Q statement is true, that implies that Sam is present. So what will happen now? That Ram is absent and Sam is present. So the statement I given you yesterday is false. Now I am considering the case number 3. Case number 3, which is if Ram will come, that statement is true, that means P statement is true, and Sam will come, Q statement is false, then what will happen? The whole statement will be false, because the whole statement will only be true when Ram and Sam both come. Let me considering the case number 4. P is true and Q is true, which implies both Ram and Sam come today, and the statement I gave you yesterday was true. That is all the possible 4 cases of these statements. This table is called truth table. In digital electronics, true value is represented as 1 and false values are represented as zeros. So let me write 0 instead of F, that means false, and 1 instead of T for true. AND gate is represented using this D-like symbol. These two lines is called input lines. Let me write it down. And this line is called output line. There can be only one output line and two or more than two numbers of input line in an AND gate. After getting the input, AND gate process the inputs in this portion, and after processing, AND gate produce some output and passes through the line. Now I will show you how AND gate actually works in real life. I write down both the truth table and the diagram of AND gate. In the truth table we have two values, one is 0 and one is 1. 0 means electric off and 1 means electric is on. Let me assume two input as P and Q. If case number 1 happens, that means P line is 0 and Q line is 0, which implies that P line is off and Q line is off, then the AND gate produce output 0, which means off, as output. If we consider case number 2, that means if P line is 0 and Q line is 1, then also AND gate will produce 0 as output, which means this electric line will be off. There are other two cases also, which is case number 3 and case number 4. Now I am considering case number 3. That means if P is 1 and Q is 0, then also P dot Q, that means the output will be 0 according to the truth table. And if we see the case number 4, that means P is 1 and Q is 1, then and only the P and Q will produce output 1. This is how actually AND gate works in. Let me visualize you through circuit simulator so that you have a crystal clear idea. See, P and Q, both switches are off. That means P equal to 0 and Q equal to 0. And you can see a light is attached with the output of the AND gate, which is also off. Off means 0 and on means 1. Suppose if I turn on the switch P, then what will happen? See, the switch became red color. That means P switch is on and the line attached with P is became red. So that means P equal to 1. Now we will see each case of the truth table. First case, which is P equal to 0 and Q equal to 0. As you can see, both the switches are off. Hence, P dot Q light is equal to false. That means 0. So our gate is working perfectly. Now we are moving to the next case. That means P equal to 0 and Q equal to 1. I made Q equal to 1, but still output is 0 and P dot Q light is off. Now we are moving to the case number 3. That is P equal to 1, Q equal to 0. I am turning on P equal to 1 and Q equal to 0. You can see still the output is 0. Now we are moving to the last case, which is case number 4. That is P equal to 1 and Q equal to 1. You can see P dot Q light is on. So we can conclude that if any input of AND gate is false, then the output will also be false. Now I am going to provide you some important points you need to remember for this topic. First one is, there can have more than or equal to 2 number of input lines in an AND gate. Second one is, there are 2 to the power n number of possible input cases where n is the number of input. Third one is, if any input of AND gate is 0, then the output will also be 0. And the fourth and last one is there can have only one output of a logic gate. My dear students, if you have any doubts or questions, please feel free to ask me. Now I am going to end this session. Thank you very much.